Welcome to SERVOsoft, the optimal solution. This tutorial showcases the winder hanging load model. The winder model is a fully dynamic model that considers the motion profile, inertia, mass, tension due to the hanging load, and gravity effects throughout the entire range of motion of the sequence. Let's look at a sample project. The project is a winder center-driven hanging load. So first, I will rename the axis to hanging load. I will then select the winder center-driven axis type. I will set the efficiency to 97% to account for some losses. Next, using the inertia calculator, I will find the roller inertia. The roller inertia is 1,988 kilograms centimeters squared. I will now press Add New Element to Total. And now that all the drive parameters are set, I will press Apply and switch to the Materials tab. On the Material tab, select the Spooler and Hanging Load checkboxes to activate them. Once selected, enter your material parameters. The web tension is going to be 0 newtons because it is not used in a hanging load application. Rather, the hanging load is the tension force on the material. Now, we will enter the parameters for the hanging load. And using the inertia calculator once more, the calculator has found the pulley inertia to be 84.82 kilograms centimeters squared. Press Add New Element to Total. We will now switch to the Limits tab and set a tension limit as a safeguard that will be caught in system check should it be exceeded. Now I will define a move for this application. Using a 1 meter per second feed rate and the 1/10 motion rule, and hovering over the distance input, the tooltip shows a 118.7 meter distance to the full roll. So I will enter 118.7 meters to get a full roll with the last layer covering the entire width of the spool. Note that each step of the radius is a new layer on the spool. Back to the main form, we can see there's an error. Looking at system check, the hanging load starting position is too low. So I will go back to the winder mechanism and change the starting position to 140 meters. Next, I will select the gearbox from the database. We want to use a single stage but with the highest ratio available, which is typically 10:1. For this tutorial, I will select the Stober PE series gearbox, which is an appropriate class of gearbox and a good fit for this application. Next, I will select a motor from the database. For this application, we want an inertia mismatch between 3 and 7 for a decent dynamic response, as the spooler adjusts its speed with each new layer. For this tutorial, I will select a Baumüller motor and switch to the Drive tab to select a matching Baumüller drive. Note, the selected drive's inverter, continuous, and peak torque curves are shown over the motor torque curve. The selected motor and drive are a good choice for our application. The winder center and surface-driven topic is explained in detail in the help file. To load the help page, open the winder mechanism and press F1. It covers everything discussed in this tutorial and also shows the actual formulae for the winder spooler hanging load. This concludes the tutorial on the winder hanging load model. Thank you.